Iridium Communications Inc. is a company, based in McLean, Virginia, United States which operates the Iridium satellite constellation, a system of 66 active satellites used for worldwide voice and data communication from handheld satellite phones and other transceiver units. The Iridium network is unique in that it covers the whole Earth, including poles, oceans and airways. The company derives its name from the chemical element iridium. The number of satellites projected in the early stages of planning was 77, the atomic number of iridium, evoking the metaphor of 77 electrons orbiting the nucleus. The satellites are frequently visible in the night sky as satellite flares, a phenomenon typically observed as short-lived bright flashes of light. History: the Iridium Communications Service was launched on November 1, 1998 by what was then Iridium SSC. The first Iridium call was made by Vice President of the United States Al Gore. Motorola provided the technology and major financial backing. The logo of the company was designed by Lander Associates, and represents the Big Dipper. The founding company went into Chapter 11 bankruptcy 9 months later, on August 13, 1999. The handsets could not operate as promoted until the entire constellation of satellites was in place, requiring a massive initial capital cost running into the billions of dollars. The cost of service was prohibitive for many users, reception indoors was difficult and the bulkiness and expense of the handheld devices when compared to terrestrial cellular mobile phones discouraged adoption among potential users. Mismanagement is another major factor cited in the original program's failure. In 1999, CNN writer David Roth detailed how he applied for Iridium service and was sent information kits, but was never contacted by a sales representative. He encountered programming problems on Iridium's website, and a runaround from the company's representatives. After Iridium filed bankruptcy, it cited difficulty gaining subscribers. The initial commercial failure of Iridium had a damping effect on other proposed commercial satellite constellation projects, including Teledesic. Other schemes followed Iridium into bankruptcy protection, while a number of other proposed schemes were never constructed. At one stage, there was a threat that the Iridium satellites would have to be deorbited. However, they remained in orbit and operational. Their service was restarted in 2001 by the newly founded Iridium Satellite LLC, which was owned by a group of private investors. Although the satellites and other assets and technology behind Iridium were estimated to have cost on the order of $6 billion, the investors bought the firm for about $35 million. In 2008, as part of a rebranding campaign by Media Graphics, Incorporated, the logo would be redesigned with updates to corporate color palette and font treatment. On February 10, 2009, Iridium 33 collided with a defunct Russian satellite, Cosmos 2251, 800 kilometers over Siberia. 2 large debris clouds were created. Present status: Iridium Satellite LLC merged with a special-purpose acquisition company created by the investment bank Greenhill & Company in September 2009 to create Iridium Communications, Incorporated. The public company trades on NASDAQ under the symbol IRDM. The company had 611,000 subscribers as of the end of December 2012. Revenue for the full year 2012 was $383.5 million with operational EBITDA of $250.7 million. The system is being used extensively by the U.S. Department of Defense through the DoD Gateway in Hawaii. The service revenue to governments made up 23% of Iridium's revenues in 2012. An investigation was begun into the DoD contract after a protest by Globalstar to the U.S. General Accounting Office that no tender was provided. A hold against the contract was lifted at the request of the Department of Defense, which cited national security reasons. This allows the continued use of the network during the investigation. The commercial gateway in Tempe, Arizona, provides voice, data, and paging services for commercial customers on a global basis. Typical customers include maritime, aviation, government, the petroleum industry, scientists, and frequent world travelers. Iridium satellites are now an essential component of communications with remote science camps, especially the Amundsen Euroscott South Pole Station. In December 2006, an array of 12 Iridium modems was put online, providing continuous data services to the station for the first time. Total bandwidth is 28.8 kbits. Matt Desch is the CEO of Iridium LLC. Hosted Payload Alliance. Iridium is a founding member of the Hosted Payload Alliance, a satellite industry alliance formed to increase awareness of the benefits of hosted government payloads on commercial satellites. Membership in the HPA is open to satellite operators, satellite manufacturers, system integrators and other interested parties. Iridium Satellite Constellation. The Iridium system requires 66 active satellites in orbit to complete its constellation, and spare satellites are kept in orbit to serve in case of failure. The satellites are in 6 polar low Earth orbital planes at a height of approximately 485 miles. Satellites communicate with neighboring satellites via Ka-band inter-satellite links to relay communications to and from ground stations. Most of these satellites were launched in the late 1990s before the company went through bankruptcy. Since the bankruptcy, only 7 additional satellites have been launched, but an updated constellation of 66 satellites called Iridium Next is currently being developed and is planned for launch between 2015 and 2017 on SpaceX Falcon 9 launch vehicles from Vandenberg AFB Space Launch Complex 3 in California. Subscriber equipment handsets the former Iridium provided phones from 2 vendors, Kyocera and Motorola. The Motorola 9500 phone is a design from the first commercial phase of Iridium, whereas the 9575 model is the current version of the handset and was released in 2011. Until the release of the 9555 in 2008, the 9505A was the sole handset sold by the company, a functionally identical clone of the Motorola 9505 with some slightly different components. In 2011, a highly durable Iridium Extreme phone was introduced with a built-in GPS emergency button and interface to advanced location-based services. An accessory was also introduced at the same time called Iridium Access Point, which, when connected to a 9555 or Extreme phone, creates a Wi-Fi hotspot for smartphone email, SMS and web connections. Kyocera phone models SS66K and SD66K are no longer in production but still available in the second-hand and surplus market. The KIG100 phone is a small 900 MHz GSM phone that fitted in a cradle that included a large antenna and facilitated connection to the Iridium network. The SS66K is a self-contained phone, but features a rather unusual ball antenna. All handsets can receive SMS, but only the 9505, 9505A, 9555, Extreme and those based on the 9522 can send them. Iridium Extreme Euro jet water, shock and dust resistant, as well as GPS-enabled handset, operating temperature -15 plus 35 degrees Celsius, launched in September 2011. Iridium 9555 a Euro A satellite handset with integrated speakerphone and hands-free capability, launched in late 2008. USB data interface with a USB to RS-232 bridge chip. Iridium 9505A a Euro large brick-shaped satellite handset manufactured from 2002 to 2008 by the second corporate incarnation of Iridium. Externally almost identical to the original Motorola 9505. Native RS-232 data interface with proprietary pin-out adapter. Motorola 9505 a Euro large brick-shaped handset manufactured from 1999 to 2002 by the first corporate incarnation of Iridium. Native RS-232 data interface with proprietary pin-out adapter. Kyocera SS66K a Euro manufactured in very small numbers by Kyocera in 1998 to 1999 for the first Iridium Corporation, very large handset. Can occasionally be found for sale on eBay. Pages 2 pages were made for the Iridium network a Euro the Motorola 9501 and Kyocera SP66K. These are one-way devices that could receive messages sent in the form of SMS. Equals other satellite phones equals, several other Iridium-based telephones exist, such as payphones, bag phones, car phones and equipment intended for installation on ships and aircraft. A handset made by NAL Research combined with a 9522 transceiver is used for some of these products. The DPL handset provides a user interface nearly identical to that of the 9505 series phones. Standalone transceiver units equals, these can be used for data logging applications in remote areas, now a common practical use for Iridium's services. Some types of buoys, such as those used for the tsunami warning system, use Iridium satellites to communicate with their base. The remote device is programmed to call or send SBD messages to the base at specified intervals, or it can be set to accept calls in order for it to offload its collected data. Most of these units can be connected to a handset and used as a fixed telephone. The following transceivers have been released over the years: Iridium Core 9523, a Euro similar to the 9522B, a modular transceiver released in 2012, designed to be an embedded solution. Iridium 9522B, a Euro A transceiver released in late 2008, is smaller than the 9522A and has similar features. Iridium 9522A, a Euro based on the 9522, some variants have built-in GPS and autonomous reporting functions. Supports SBD. Motorola 9522, a Euro last Motorola transceiver, supports outgoing SMS but no SBD. Motorola 9520, a Euro original transceiver module, does not support outgoing SMS or SBD. Designed for use in vehicles with accompanying handset. SBD modems, these devices support only short-burst data for M2M services and do not use a SIM card. Iridium 9601, a Euro supports only SBD, several tracking devices and other products have been built around this modem. It was an Iridium manufactured product designed as an OEM module for integration into applications that only use the Iridium short-burst data service. Short-burst data applications are supported through an RS-232 interface. Examples of these solutions include maritime vessel tracking or automatic vehicle tracking. Iridium 9602, a Euro smaller, cheaper version of 9601. Iridium 9603, a Euro 1/4 the volume and half the footprint of 9602. SIM card equals, removable subscriber identity modules are used in Iridium phones, much like those used for GSM. Prepaid SIM cards are usually green while postpaid cards are red. The 9602 Solomon Islands dollars modem does not use a SIM card, it is identified by the network solely through its IMEI and the customer account associated with that IMEI. OpenPort OpenPort is a broadband satellite voice and data communications system for maritime vessels. The system is used for crew calling and email services on sea vessels such as merchant fleets, government and navy vessels, fishing fleets and personal yachts. Iridium, a Euro unregistered trademark S global service program, provides shipboard technical support to Iridium OpenPort customers. OpenPort voice services are billed by the minute as with handheld phones, while data services are billed by the megabyte of data transferred. Services, calls from Iridium phones can be made to any landline or wireless device in the world and typically cost between 75 cents to $1.50 per minute. Calls made to Iridium phones can be very expensive, costing several dollars per minute. For example, Google Voice charges $4.03 USD per minute to directly call an Iridium phone. It is possible to call with charges reversed by first dialing a number in Arizona. The call is charged to the receiver at the standard rate for satellite to landline calls, but the caller only pays for the call to Arizona. Since Iridium will not sell prepaid cards or even its subscription call service directly, it is hard to obtain the exact price of making a call. There are numerous distributors that will activate Iridium phones and sell prepaid vouchers and SIM cards. Voice and data calls equals, the Iridium system deals with minutes, which are subdivided into several much smaller units. These minutes are the basic rate to landlines and ordinary mobile phones around the world. For a 500-minute annual plan, the cost of the basic rates fluctuates around $1.25 per minute, depending on the distributor. There are also regional plans that offer slightly cheaper rates than the normal, but these minutes can only be used in a specified geographic location. Calls to landlines worldwide, 1.00 basic rate. Calls to other Iridium phones or voicemail, 0.50 sending SMS messages, 0.33 calls to other operators' satellite phones, 5.00 euro 13.50 data calls, 1.00 Iridium and other satellite phones may be identifiable to the listener by the clipping effect of the data compression and the latency due to the electronic equipment used and the distances the signal must travel. The voice codec used is called advanced multi-band excitation. Iridium operates at only 2.2 to 3.8 kbits, which requires very aggressive voice compression and decompression algorithms. Latency for data connections is around 1800 milliseconds round-trip, using small packets. Despite the bandwidth limitations, transparent TCP/IP is supported. Iridium claims data rates up to 10 kilobits per second for their direct internet service, which utilizes V42 bis compression over a PPP dial-up connection to Iridium's Arizona gateway. Actual data rates remain at 2300 to 2400 bits for any compressed data such as a JPG image or zip file, but plain text or HTML may transfer up to 10 kbits. Iridium 9500, 9505 and 9505A phones can be connected to computers using an RS-232 connection, as can the 9522A transceiver module. The 9555 and Extreme phones connect to computers with a standard USB cable, using an internal USB to serial bridge chip in Windows drivers to emulate a serial COM port for compatibility with standard PPP clients. Prepaid service prepaid SIM cards are available from a variety of different outlets and sometimes appear on auction sites such as eBay. Their values range from 50 to 5,000 minutes. The 50-minute cards have no validity and the 75-minute vouchers are valid for only a month, but the 5,000-minute cards stay valid for 2 years. Since Iridium charges quite a bit for merely accessing their network without making calls, it is possible to extend the validity of such an account by a month for around $45. It is also possible to refill such an account without purchasing a new SIM card. The 500-minute card is the most common one, which remains valid for 1 year and can usually be bought for $600 to $750, while the 75-minute card can cost up to $175 and the 5,000-minute card costs around $4,000. Postpaid service there is a basic emergency plan for around $30 to $40 per month that offers no minutes at all, with calls charged at around $1.39 per minute, and also numerous plans with included minutes. For the more expensive plans, the per minute price dips slightly below $1. Phone numbers Iridium controls the virtual country codes +8816 and +8817, part of the 881 range designated by the ITU for the global mobile satellite system. Each subscriber is given an 8-digit number prefixed by one of these country codes. However, many regional telephone service operators have no interconnect agreement with Iridium or other satellite networks, and users on these networks need to call reverse charge to a US-based number. It is also possible to call an Iridium phone by using a US-based gateway number at the Arizona gateway. In this arrangement, a person wishing to call an Iridium phone dials +1 480 768 2500. Billed at the standard rates to call the United States from their location, waits for the prompt, enters the +8816 or +8817 number of the Iridium phone they are attempting to reach, and the network then attempts to complete the call. If the Iridium subscriber answers their phone, it will be billed at its standard usage rate, ranging from 95 cents to $1.50 USD per minute, or subtracting minutes from a pool of prepaid minutes assigned to the phone. Since spring 2007, Postpaid Iridium subscribers have an option to associate their Iridium numbers with a direct US-based number. Paging service the one-way paging service is still operational, despite the pagers not being in production for many years now. Messages are delivered to pre-selected MDAs, which cover a certain geographic area. 3 of these MDAs may be selected on a web-based portal or updated automatically if the paging service is bound to an Iridium phone. Each country has its own MDA based on its country code. Some of the larger countries are divided into several MDAs, while separate MDAs exist for sections of ocean and common aeronautic routes. This service costs around $70 per month with a limited number of messages allowed, or $140 for an unlimited number of inbound messages. Pagers are assigned with telephone numbers in area code 480 and can also be contacted using email, SMS and the web-based interface used to send messages to Iridium phones. Short burst data special modems such as the 9522A, 9601, 9602 and Quake 9612 can be used for sending and receiving short data bursts, less than 2 kilobytes at a time. This service is often used for asset tracking and remote monitoring. Messages are converted to be delivered in email format or over HTTP to a pre-configured address. The mobile unit does not include a destination address when sending a SBD message. A crude positioning report is also included in each message sent. SBD messages take from 6 to 22 seconds to send or receive. The latest generation of SBD transceiver, the Iridium 9602, can receive up to 270 bytes per SBD data message and can transmit a maximum of 340 bytes per SBD message. A real-world example of the 9602 chipset in use is the YB tracker. Value-added services, to check emails can be very expensive. To avoid this there is a service called Sat Notify by Leaf Consulting which checks emails periodically and send a text message to the satellite phone, if there are new messages. Air Safety Communications. In July 2011 the Federal Aviation Administration issued a ruling that approves the use of Iridium for future air navigation system data links, enabling satellite data links with air traffic control for aircraft flying in the FANS environment including areas not served by Inmarsat which includes polar routes. Technical details. Air interface communication between satellites and handsets is done using a TDMA and FDMA-based system using L-band spectrum between 1616 and 1626.5 MHz. Iridium exclusively controls 7.775 MHz of this and shares a further 0.95 MHz. In 1999 Iridium agreed to timeshare a portion of spectrum, allowing radio astronomers to observe hydroxyl emissions. The amount of shared spectrum was recently reduced from 2.625 MHz. External hockey puck-type antennas used with Iridium handheld phones, data modems and SBD terminals are usually defined as 3 dB gain, 50 ohm impedance with RHCP and 1.51 VSWR. As Iridium antennas function in frequencies very close to that of GPS, a single antenna may be utilized through a pass-through for both Iridium and GPS reception. The type of modulation used is normally DEQ-PSK, although DEB-PSK is used on the upper link for acquisition and synchronization. Each time slot is 8.28 milliseconds long and sits in a 90 milliseconds frame. Within each FDMA channel there are 4 TDMA time slots in each direction. The TDMA frame starts off with a 20.32 milliseconds period used for simplex messaging to devices such as pagers and to alert Iridium phones of an incoming call, followed by the 4 upstream slots and 4 downstream slots. This technique is known as time division multiplexing. Small guard periods are used between time slots. Regardless of the modulation method being used, communication between mobile units and satellites is performed at 25 kilobaud. Channels are spaced at 41.666 kHz and each channel occupies a bandwidth of 31.5 kHz. This allows space for Doppler shifts. Handoff. The Iridium system uses 3 different handoff types. As a satellite travels over the horizon, calls are handed to adjacent spot beams. This occurs approximately every 50 seconds. A satellite only stays in view for 7 minutes at the equator. When the satellite disappears from view, an attempt is made to hand the call to another satellite. If no other satellite is in view, the connection is dropped. This may occur when the signal from either satellite is blocked by an obstacle. When successful, the inter-satellite handoff may be noticeable by a quarter-second interruption. The satellites are also able to transfer mobile units to different channels and time slots within the same spot beam. Earth base stations Iridium routes phone calls through space. In addition to communicating with the satellite phones in its footprint, each satellite in the constellation also maintains contact with 2 to 4 adjacent satellites, and routes data between them, to effectively create a large mesh network. There are 4 Earth stations which link to the network through the satellites visible to them. The space-based backhaul routes outgoing phone call packets through space to one of the Earth station downlinks. Station-to-station calls from one satellite phone to another can be routed directly through space without going through an Earth station. As satellites leave the area of an Earth station, the routing tables are updated and packets headed for the Earth station are forwarded to the next satellite just coming into view of the Earth station. Communication between satellites and Earth stations is at 20 and 30 GHz. Gateways are located in Tempe, Arizona, Waioa, Hawaii. Owned by Defense Information Systems Agency, the pre-bankruptcy corporate incarnation of Iridium built 11 gateways, most of which have since been closed. Gateways were also built in Pune, Beijing, Moscow, Nagano, Seoul, Taipei, Jeddah and Rio de Janeiro. The company is seeking to reactivate gateways in Russia and China to comply with national laws in those countries. Other technical information like other satellite networks, Iridium terminals need open line of sight to open sky in order to function. For instance, units will not work consistently indoors, or under forest cover. Iridium does have a very powerful paging channel that can ring the phone indoors, but the customer may have to walk outdoors to take the call. There is a web email to SMS gateway which enables messages to be sent from the Internet or an email account to Iridium handsets for free. There is also a voicemail service. Iridium generally does not have roaming agreements with terrestrial cellular operators. Telstra in Australia allows postpaid GSM subscribers to use their SIM card. However, global roaming has to be activated and both incoming and outgoing calls are charged to this account, and the call rate is around $4 per minute. The incoming calls are via the GSM phone number of the account, with country code, etc., prefixed. In order to use the network, it is necessary to have not only appropriate equipment, such as a handset or the optional cellular cassette for the Motorola 9505 phone, but also a pay-as-you-go or contract Iridium SIM card. Tracking transceiver units without an extra global navigation satellite system, receiver tracking is difficult, but not impossible, as the position of a mobile unit can be determined using a Doppler shift calculation from the satellite. These readings however can be inaccurate with errors in the tens of kilometers. Even without using Doppler shifts, a rough indication of a unit's position can be found by checking the location of the spot beam being used and the mobile unit's timing advance. The position readings can be extracted from some transceiver units in the 9505A handset using the MSGEOAT command. In the past, Iridium has used this method of tracking to block service to U.S. embargoed countries, such as North Korea and other politically unpopular regions, such as northern Sri Lanka. It is also used to stop geographically bounded plans from being used outside the designated area. The Iridium Extreme phone introduced in 2011 has a GPS location service embedded in the device, which the user can use to locate themselves or include in SMS messages. It can also be used to provide advanced services like geofencing. A red emergency button on the top of the unit can be pressed to send the unit's position to emergency rescue agencies or other number pre-programmed by the user or distributor. See also, 2009 satellite collision, Broadband Global Area Network, Globalstar, and Mersat, Iridium Flare, SES Broadband, O3B, Orbcom, Skywave Mobile Communications, Thuraya, Quake Global. References. External links, official website, application of Iridium telecommunications to oceanographic and polar research, Iridium data modem, technical success and economic failure, MIT, view current Iridium constellation, Quake Global SBD modem provider, Iridium Pager 9501/SP66K advanced programming utility, Iridium 9501 and Kyocera SP66K pager software applications. Hot Pepper Technology, Incorporated.